Let's continue. What type of association rules that we can have? So association rules can have three types of rules: actionable, trivial, and inexplicable rules. So what is actionable? Contain high quality actionable informations. Trivials, information already well known by those familiar with the business. Yeah, well known. This is high quality actionable. There is an action that you can do with your rules. Yeah. Trivials, already well known. Inexplicable rules, no explainable, do not have any suggestion. It's not that good, yeah, because there's no explanation at all. Trivial and inexplicable rules occur most often. So these two things together, yeah, sometimes we can have well-known rules or this one, inexplicable rules. Okay, so this is about the process how we create association rules. We need to choose the right set of items. So for example, from the topping of the pizza. Yeah, first we need to determine the right set of the items and the right level. For instance, is pizza an item or are the toppings items? Yeah. So whether we want to pick this base, the pizza or the topping as the data that we want to learn. Yeah. Okay, so now we calculate the topping. So we pick the topping because we want to choose the right set of items. So we pick topping as the items. Okay, next step is generating rules by deciphering the counts in the co-occurrence matrix. Okay, as I explained before, we create a matrix explaining the co-occurrence of the items. Okay, next calculate the probability and joint probabilities of items and combination of interest, perhaps limiting the search using threshold on support or value. So we can have something like this. If mushroom, then people will pick pepperoni. Okay, overcoming the practical limits imposed by thousands or tens of thousands of unique items. Okay, so from this table, probability table, we can have, for example, how many times this mushroom appear in the order. Yeah, for example, oh, it's only 30 times over 100, so we have 30%. How about the pepperoni? Oh, maybe this is 30 times over 100 occurrence. Yeah. So from here we can build these kind of rules and then finally analyze the probabilities to determine the right rules. So these three, 1, 2, 3 step can create the association rules. Okay, let's go to the practice. Okay, for example, given this point of sales transactions data like this, yeah, we have only 5 transaction data and each transaction has different item, yeah, that bought by the customer. For example, pen, bread, and butter. This is customer number 1 or purchase number 1, yeah. Okay. Okay, we want to use the association rules mining to find something like this. If the customer buy bread, they can also buy butter. If the customer buy vegetable, they can also buy milk. If the customer buy fruit, they can also buy egg. So this is trivial rules, yeah? Remember, the business can already know this kind of rules. Implication here means co-occurrence, yeah, not causality. What does mean? Not causality. That's mean if people buy bread, that's mean this guy is buying butter as well together. Doesn't mean that because you buy the bread, you have to buy butter. Now, that's called the causality. It's not the causality, but co-occurrence. Okay. Okay, so before we can solve the problem, we need to know about the common metrics. One is support and 2 or 3 is confidence and lift. So these two is optional. So you can either use confidence or lift and confidence together. But this one is mandatory, yeah. So every association rules always use the support. This is like threshold. So why do we need these 3 metrics? Because we don't want to calculate every single possibility. So we can prune some other infrequent occurrence based on the threshold that we already decide. So these 3 threshold is given by the human, by the user. Okay, let's see. Support. We have what we call support. What is support? Support means the rate of frequently bought item or the combination of item bought frequently. So it's like probability. Yeah, for example, this is the formula. Support of item I equals to the number of transactions containing item I divided by the whole number of transactions. This is easy because we just calculate how many times this item bought in the whole transactions. For example, support of bread. Okay, we can see how many times bread bought in this data sets. Yeah, 1, 2, 3, 4. So we have 4 in here out of 1, 2, 3, 4, 5 transactions. So the support of item bread equals to 4 of 5, 4 over 5, 4/5, yeah? Okay, so now how about the confidence? Okay, this is the conditional probability of occurrence of a consequence, then providing the occurrence of the antecedent. So what is antecedent? What is consequent? The antecedent is the first event, and then the next event called the consequent. If a customer buys a loaf of bread antecedent, he is supposed to buy butter as well as the consequent. Yeah, this is occurrence. Yeah, this is not causality, but we call the first one is antecedent and the second one is consequent. So the bread as the antecedent, the butter is the consequent. Okay, so for example like this, bread and butter, bread and butter, bread and butter, and bread and butter. Okay. So for example, we want to calculate the confidence of item 1, then item 2. For example, item 1 is bread, item 2 is butter. Okay. How to calculate this? Transaction containing both, both item 1 and item 2 together, divide by transaction containing item 1 only from this, only from the whole transaction that contain item 1. So the antecedent, okay, antecedent. Yeah, so you divide by the number of antecedent. So if we see bread and butter in here, we have 1, 2, 3, 4. Transaction containing both bread and butter is 4. How about transaction containing bread only? Okay, we can see bread only. 1, 2, 3, 4. So we have 4. Yeah, this one. So if we calculate 4 out of 4, 4 over 4 equals to 1. What this number means is the confidence of bread and butter is 4 out of 4. That's mean this one. 1 is the confidence value equals to 1. That's mean Y is always purchased whenever X is purchased. So that's mean this is antecedent, this is the consequence, always both together. Okay. So there is no single event that Y is both without X. So that's how you read the confidence value. How about 0? 0 is the reverse, yeah, the other way around. Y is never purchased when X is purchased. Okay, I need to highlight this statement below. The confidence measure is directional. Okay, remember, directional means if you have confidence of X, then Y, and then you want to calculate again the confidence of Y, then X, these two value is not the same. You know why? Go back to the formula. This one comes from the occurrence of these two together, X union and Y, yeah. The divide by the number of X. And this one, the frequency of Y union X divided by the frequency of Y, right? That's why this is not the same. That's what we call directional. Okay, now how about lift? Okay, lift is the ratio of confidence and support. It tells how likely an item is purchased after another item is purchased. Okay, different with the other measurement, confidence. Confidence has direction, but here lift has no direction. So if you want to calculate lift, yeah, lift of item 1, then item 2, and then lift of item 2, then item 1. This 2 is not equal. Oh, sorry, these 2 is equal. Okay, so this 2 is equals. Why? Because they has no direction, so this is the same. Okay, the likelihood to buy butter if a customer buy a loaf of bread. This one, and then this one. Okay, and okay, the formula is confidence of item 1, then item 2, divide by the support of item 1, multiply by support of item 2. So that's why if you want to calculate the other part, yeah, the other directions, so this is the same. So the same like confidence of I2, then I1, divide by support of I2, multiply by support of I1. So this is the same like this one. Okay, so in a priori we have two main steps. The first step is generating frequent item sets. Okay, so this is the important terms. And then the second one is generating the rules. In the first step, we're using support. In the second step, we're using confidence. This is how we use those three metrics, yeah. Okay. Okay, step number one. For example, we want to set our minimum support and confidence as 40% and confidence is also 40%. Okay, yeah. Like the first example, first we need to calculate the frequency table for the item sets. So we have this table, we have the frequency table. Yeah, for example, breadth for time, and then so the support is 80% because 4 out of 5. Okay, breadth 1, 2, 3, 4. Right? We have 4. Okay, and so on and so on and so on. Next. Okay, so we only have 1, 2, 3, 4 good item set. Good frequent item set. Why? Because, let's go back here. Now, if you see, this 3 is not good enough. Why? Because 20% is less than 40%. Yeah, this is our minimum support. So we can eliminate these 3. We don't have to include them in our next step because this only appear one time. It's not significant to build our rules. So we left with the other 4. Okay, so we only have these 4 items to be included in the next step. Here, so we have 4 item set, frequent item sets. So I can call this first set is L1. Okay, based on the L1, we can build our L2. Yeah, we repeat again the steps still to find the frequent item set. So from here, we need to start combining between each item. For example, bread and butter is from bread and butter. And then the second combination is bread and eggs. And then bread and milk. Okay. So how about the next combination? And the next combination is bread and eggs, and then bread and milk. Oh, sorry. So the next combination is butter and egg, butter and milk. Okay. And then the last combination is egg and milk. Okay, yeah, this is the all possible combination from our L1. Next. Okay, what happened next is the same. We need to calculate the support. Support again. the same like we calculate the L1 support. Bread and butter, yeah, bread and butter, bread and butter, bread and butter together, they appear 4 times out of 5 equals 80%. Okay, remember, we only want everything that above the minimum support. Inclusive, yeah. So we take everything in here for the next step. Then repeat again. From our L2, we build our L3. Yeah, the next frequent item sets. So this is the same way. But bread, butter, and egg together. Bread, butter, and egg. Okay. This item and this item. Bread, butter, and milk. Bread, butter, and milk. This one and this one. Bread, butter, and egg. Bread, butter, and egg already. Bread, butter, and milk. Bread, butter, and milk already here. And then what this one? Bread, butter. No, there is no possible combination between this and this one, right? Okay. How about the next combination is this one together, bread and egg and milk. Okay. Bread and egg and butter. Bread, egg, and butter already. Bread and egg and no, we cannot use this and this together. This one and this one, bread, egg, and milk. Bread and egg and milk. Okay, done. And then next. So we have this, yeah, the last combination, butter, milk, and egg. Nah, this one. Okay, yeah. Next, we can continue to the next step. Again, we repeat the same step to calculate the support for this frequent item set L3 support. Okay, everything is good, everything is over 40%, so we can continue to the next step, L3 to L4. So the only possible combination from this L3 is only one, bread, butter, egg, and milk, right? Bread, butter, egg, and milk. Now how about the support? The support is 2 out of 5 equals to 40%. Yeah, bread, butter, egg, and milk. Bread, butter, egg, and milk. Bread, butter, egg, and milk. And then bread, butter, egg, and milk. So we have 2. Okay, it's all good. We have 40% in here. Minimum support. Yeah. What next? Because we don't have any more possible item set we can build from here. So we can stop in L4. Yeah. Bread, butter, egg, and milk. There is no more combination with other item. So algorithm stops for looking the combination of item set. Yeah, this is step 1 done. Okay, we left with, so the output from the first step is this one. Okay. Next, in step 2, remember the big step of the a priori, we want to create the association rules. Yeah. So we're going to use our frequent item sets to build the rules. How to build the rules is like this. Okay. For example, we have L for in here, bread, butter, egg, and milk. Now we need to create possible non-empty subset of L. First, we have bread, butter, egg, milk, bread and butter, and then what else? What possible non-empty subset? We can have bread and egg, yeah, bread and milk, right? And then how about the size of tray? We can have bread, butter, and milk. We can also have bread, egg, and milk. We can also have butter, egg, and milk. Yeah, this is the whole possible subset. Okay, next. The next step to build the association rules is we create the complete, with L minus S, which means we complete these rules with the rest. Okay, so if we have bread, so the rest item will be butter, egg, and milk. If we have butter, the rest will be bread, egg, and milk. And then we give these arrows in here. Okay, so go back to here. For our example, we have bread, so we left with butter, egg, and milk, right? How about if we have butter? We have egg, we have bread, we have milk. How about egg? Okay, so the rest will be bread, and then butter, and then milk. Okay, and so on and so on and so on. And this one is easy. You can only have egg. This one we can only have butter. And this one we can only have bread. Okay, then what next is we're going to calculate the confidence. Okay, the confidence is our threshold. Yeah. How to calculate the confidence? Following the formula, we need to calculate the support of A union B. Yeah, this antecedent together with this consequence. So bread, butter, egg, milk together is 40%. Yeah, and support of A itself, so bread, butter, and eggs, this is also 40%. Yeah, let's calculate. Okay, let's see the example. Okay, support of A is the antecedent, B is the consequent. Okay. So bread, butter, egg, milk together, bread, butter, egg, milk together 1, bread, butter, egg, milk together 2. So we have 2 out of 5. How about the support of antecedent? So this one only. Bread, butter, and egg. Yeah, okay, I change the color. Bread, butter, and egg 1, bread, butter, and egg 2. So we can also have 2 out of 5. This one divided by this one, this number equals to 2 out of 5 divided by 2 out of 5 equals to 100%. Okay, this is how we calculate the confidence. It seems that this is only some, yeah, it's not all the rules, so this is just the examples of the rules. So we can have a look. What is the complete one? It's this one. So if we see in here, the whole rows that that we can build from the last frequent item sets is all over 40%. Yeah. This is the minimum confidence. Yeah, so the confidence is all above the minimum. Okay, let's see this. The confidence, yeah, this one, all above the minimum confidence level. Okay, so this is the output of the a priori algorithm. Okay, so this is the end of the a priori as association rules mining algorithm.